Hi there, today we're taking a look at the Amstrad PCW-8256 or PCW-8512. Basically these machines are quite identical except for another floppy drive in the 8512 and of course some more RAM, as the name alludes to. The machine itself is a CPM based machine, and it was basically used for word processing. The computer itself is inside the monitor, and it comes with a really nice keyboard and also a dot matrix printer. So it was a complete system and ready for use. The machine is quite unique in several ways. First of all, because of the operating system, which was CPM, and also because the floppy drives are these funny 3-inch discs. So the drive itself is single-sided, but the disc can be flipped. So most of them have the operating system on one side, like this one, CPM 2.2, and the other side it has some programming language called Dr. Logo. And hopefully we can get this machine working, and we can play around with it a bit afterwards. These machines basically all fail in the same way, and it's very basic. Inside the floppy drive there's a rubber belt, and that rots away over the years. So to get this thing working, it should be just a matter of swapping the belt. I do actually have two of these machines. This one, which is branded Schneider, which was for Germany and the Netherlands and some other countries in Europe. The other one is branded Amstrad. I will start by repairing the Schneider one. The Amstrad one seems to be working as well, but the Amstrad machine has a very high-pitched noise from the flyback transformer. And basically I need to dip it in lacquer or something to get all the windings to stick together again. But just to get something running and something I can play with, because I really like this machine a lot, I'm going to repair the Schneider one first. So the main unit consists of a green monitor, all the electronics for driving the monitor, the computer mainboard itself, and the floppy drives. The only thing that is external is the keyboard and the printer. So to get to it, I need to remove the stand from this first and then try to open up the cabinet. Okay, and we got the back cover off. Okay, so we're looking in from the back, and we have of course the CRT here, and it looks like a 14-inch monitor from Orion in Korea, I guess. And there's a big high voltage PCB below, and it has all the drivers and the flyback transformers for generating the high voltage and stuff like that. This machine has not been plugged in for literally months, so I think it's quite safe to take a peek inside. If we look down on the power PCB, there are two things happening. First of all, there's the high voltage circuit over here. The flyback transformer is this big plastic thing. You can see the high voltage lead going to the CRT down here. Apart from that, on the left, down here underneath, there's actually a switch mode power supply, and that drives the main board. So the hardware is quite straightforward for that. You can see a lot of heat sinks and stuff, and that is good. It looks well made. Okay, so to the left of the CRT there's the main PCB. The floppy drive is down here, and you can see there's room for one more just to the right of it. So if you add one more floppy drive and add extra RAM to the main board, you have a PCW-8512. But I'll do that some other time. Now we just got the machine running first. The floppy drive is mounted with 4 fairly long screws. And yeah, they're really long. 1, 2. Amstrad was of course a trading company named after the founder, Alan M. Sugar. So AMS Trading. And yeah, it was just a trading company, so I'm not sure who he got to make these machines for him. But they're very well made, and they had very good specs. Always better spec than the competitors basically, and at a lower price. And I guess that's what sugar made him rich. Okay, and we got the floppy drive out. Okay, so this is the main board, and apart from the high voltage circuit for driving the CRT, that's all there is to this machine. And if we just look at the chips first, we have of course the Z80 CPU, and this machine is running CP/M. CP/M is actually a very simple operating system. It runs in very little memory, and this CPU of course can only access 64 kilobytes of RAM. So machines like this that have more RAM than 64K, they're using what's called bank switching. In this case, as far as I know, the lower 32 or 48 kilobytes of RAM is always the same. And then the upper 16K, they're switching in different parts of memory. And that is not a new technique. That was used back in the early 80s as well. And if you look at the normal PC, the original Intel CPU, the 8080 and the 8088, they were all using this kind of bank switching to access more memory. Of course, programming becomes difficult, but if you use the bank switching memory for storing data and having the program in the lower memory, then that works out pretty good. As I said, CP/M is a very simple operating system. You don't need a lot of logic, and I'm sure that is what made this Amstrad machine so cheap. So basically, so apart from the CPU and the memory out here, we have the Amstrad ASIC in the middle here, and that must be a very low gate count device. CP/M, as I said, is very simple. On the left out here, we have a floppy disk controller. This is a standard D765, and that is used a lot of times. The signals to the floppy drive goes through a couple of buffers here, and that's it for the floppy drive. Then we have the boot ROM. In CP/M, the boot ROM is also bank switched. Because there's so little memory available, during power up, the CPU will run the code in the boot ROM here. And that code, the only purpose it has is to load the actual operating system through the floppy drive into memory and start executing it. As soon as the operating system is loaded, code in the ROM itself will issue a command that will switch out the ROM, and the space that was taken up in memory by the ROM is now free to be used for normal program code. So there's a little trick about switching the ROM in and out during power up, and that is of course also handled by the Amstrad chip here. And the final chip is this one here, which is also an Amstrad device, and that takes care, as far as I can see, of the printer port. So that leaves the video generation, and that has to happen down here. I don't see any other chip for that. Yeah, that's about it for this Amstrad machine. And actually back in the late 80s, early 90s, I made a CP/M machine myself without any ASIC, just based on the TTL gates. And that was on a Euro card. Unfortunately, I don't have it anymore, but I do have a photo of it somewhere. And it basically just sits on top of a floppy drive. So that's it. Let's fix the floppy drive problem, and we should be able to get this machine up and running. Okay, so this is the floppy drive, and it's a 3-inch drive, as I said earlier. And it is mounted in a metal enclosure here, and basically that's just for holding it in the chassis. So we remove the shell first, so we can get to the motor and the head and all the electronics inside. So that should be quite straightforward. This machine is from 1985, and of course CP/M was already back then, but this machine is enough, so yeah, I'm sure it was a very old bug really. Okay, so this is the drive, and the motor is here for spinning the disc, and there's a stepper motor here for moving the head back and forth. And that's it really. So we need to get to the capstan down here. And that's it, two screws. And can you get it out? Careful. You can see the drive belt in here, and that is really gone. Look, there's basically nothing left. There's no rubber, no nothing. I don't know, it's just a piece of Teflon strings that is totally disintegrated. So yeah, we definitely got to change that. And I bought 2 new ones from eBay, and actually that was probably a year and a half ago, so they are not in they're not in mint condition either, but they're still springy, and I'm not sure if this is visible on camera, but we have to get it around this little capstan thing down here. I think it's called a capstan, but there's a little wheel down here directly mounted on the motor, and then there's a bigger wheel out here, and we just gotta get the rubber band. Okay, like this. So now I've swapped out the drive belt here, and we can put it back together and assemble this computer, and then we should be ready to go. Okay, so it's back together, and let's try and switch it on and see what happens. I've got my CPM operating system disk ready. Let's turn it back on. Yes, it's loading. Let's zoom in on the screen. It seems to be fixed. Let's do a directory. So here you can see the awesome resolution on this screen. This is 80 characters by 24 or 25, and really high resolution. It's awesome. So compared to a lot of the other machines, this was really considered professional. Not all this color nonsense and stuff like that. This is just hardcore business only. It came with CPM, local script, which is an awesome word processor, and of course it came with a printer. So everything was awesome. But I can see here there's a program called Basic. So we should just try and run that. So this is one of the first home computers where Basic was not in ROM. It doesn't boot into Basic, it boots into a real operating system. We are in Basic now, and there are 32 kilobytes free roughly. And if we just do the little print program, you can hear it's proper clunky keys. This is great. 220 go to 10, and if we run that, whoa, hello world, and everything looks great. And there's even a little stop button up here, and we can do a list. Where's my program? There it is. So yeah, it just works beautifully. Let's flip the disk over and reboot the machine and try the word processor, because it was really famous for that. And here we have the disk manager. You can see all the different files on screen. Now, of course, there's nothing here, but if we don't load anything, but just take a new document, this should be possible. Edit XC, create new document. Okay. So we will call it Jasper. And yeah, okay, disk is write protected, obviously, because this is the operating system disk. Okay, send result to drive M. There. Okay, and I got it working. There we have a letter. You have to press enter, not return. It's 2 different things. And there's a template for my letter. You can see it's ready to type in my address and date. And then I can, of course, do hello world. It's a full-size keyboard, and it works really well. And of course, this is a CPM machine, and there are lots of CPM software available online. So yeah, I fixed it. It wasn't difficult. It took only 10 minutes, or maybe 15. And I have an awesome little machine here that I'm going to play around with, and maybe write some programs for when I have the time. So yeah, that's it for this video. Thank you for watching, and see you again soon.